start solving equations, which I know you've known how to do for a while, I just want to give you a little bit of history. We've known, as a human race, we've known how to solve for unknown values for a while too. We have evidence of ancient Babylonians solving for unknown values, as well as ancient Egyptians. The word algebra, yeah, that's me, and there's my boy Isaac. The word algebra comes from actually a Persian word, which I can't pronounce, but it's very similar to our word algebra. And the reason we use that word is because it was part of the name of the first time we ever had a book that actually formalized all the symbology of here's how we solve for an unknown. Here's this X or this unknown variable that we're looking for. So there's a bit of history. You've had a bit of history as well since 6th grade. So let's go ahead and start solving some equations. All right, guys, welcome to Unit 2A. We have split Unit 2 into 3 sections. We're going to call them 2A, 2B, and 2C. Today we're going to be talking about solving 1- and 2-step equations. Our learning target is that we can solve 1- and 2-step equations. Before we get too far, though, I want you to turn back to page 2 where your glossary is, and we just have one word we're going to define today, and that is equation. So equation is defined as a number sentence that contains an equal symbol. What we've been working with so far have been expressions where we had numbers, variables, and operations, and we were putting those together, but we didn't really have an equal sign, which means we couldn't solve for x. All those adding and subtracting polynomials, we still had variables, and a lot of you were concerned that you didn't feel like you had a real answer. And now that we're putting an equal sign in there, we will be able to isolate that variable and find an answer or a solution. So to get into our guided notes, remember please that if you have questions, write them down over here so that when we come around to talk to you, you can remember what it was you were going to ask. So our guided notes is just kind of a rehashing of the vocabulary word we just put in our glossary, and that is that an equation is a number sentence that contains an equal symbol. It is made up of 2 expressions. Again, these are the ones that we're used to using in Unit 1. To solve an equation, we have to isolate that variable. That means your number one goal, if you're trying to solve an equation, should be to get that variable all by itself so that you have a variable is equal to some number. So by the time you get to the end of an equation, you should have something that looks like this. Variable equals a number. That lets you know that you're done. That means that you're just going to rearrange it until all you've got is something that looks like this, whatever that variable means. Now, in order to do that, we have lots of properties that we can use, and some of them we've seen before, some of them not. So I'm just going to do a quick review. The addition property of equality says that if A equals B, then A plus C equals B plus C. I know that sometimes these formal definitions look a little confusing, so we've given you a spot to put it in your own words. I've typed up something that's in my words, but if you want to change it, feel free as long as it's still accurate. Basically what this means is if you add something to one side of an equation, then you have to add to the other side. We use this all the time, and you've probably done it plenty of times in 6th, 7th, and 8th grade when you were solving equations. The subtraction property of equality, same exact thing. If you've got 2 sides of an equation that have already been set equal to each other, then subtracting from one side is fine as long as you subtract from the other side as well. So if I subtract from one side of the equation, then I subtract from the other side, and it's important that you're subtracting the same amount. That's why we have the same letter here in this definition. Multiplication works the same way. If we multiply on one side, we have to multiply the other side by the same value. Division property is exactly the same, although there is this extra little complication where it says C cannot be equal to 0. That is because we are not allowed to divide by 0 in math. That will give you an error if you try to do it on your calculator. It's an undefined value. So if we divide on one side of the equation, then we divide on the other, but don't divide by 0. Distributive property, he's a good old friend. We've used him lots already. The distributive property is this, and you've seen that before, that if you've got a number being multiplied by a sum or a difference, then you are going to be distributing that a and multiplying it by each piece that's inside of your parentheses. I defined it as multiplying by a sum means multiplying each term by that value. I don't know how you want to reword that, but that's what I came up with. Now, simplifying or combining like terms we've also done lots of times, and it's going to still be important for solving equations, especially when we get into multi-step and the more complicated equations that we're going to be looking at this year. For any numbers, a, b, and x, if you've got something like this, ax plus bx, then you can combine those as long as they have the same variable with the same degree. I just put an example here. If I can find it, there it goes. I just put an example. This is just talking about situations like this. If I have 2x plus 5x, then I know that I can add that 2 and 5 to get 7. Just make sure that your variable also has the same exponent on it. All right, symmetric property of equality. If a equals b, then b equals a. That seems like a kind of duh statement, but basically what that means, well, I typed it up here. Equal signs are bidirectional. The place where you're going to find this coming up occasionally is sometimes you'll solve an equation and you'll end up with something that looks like this. And then when you go up to look at the key, it's going to look like this. And you're going to say, is it okay that it's not in the same order? And I'm going to say, yes, because equal signs are bidirectional. And because we have that symmetric property of equality that says it doesn't matter which one comes first. 2 is equal to x, the same as x is equal to 2. Substitution property says if we know that two values are equal, then we can substitute them however we like. Thank goodness this is real, because we've already used it a ton of times when we gave you an expression like, I didn't type one in, but when we gave you something like this and we said evaluate for x equals -1, and you had to plug in that -1 and solve it, that was just using that substitution property of equality. All right, so let's talk about actually solving some equations. Think of equations like scales. When two sides are balanced, if you change something on one side, then you do the same change on the other side, just like in science class. In order to help us isolate those variables, we use inverse operations. And this goes back to that inverse property we talked about in Unit 1. So the inverse of addition is subtraction. Basically, you're just thinking, what's the opposite? How can I undo something? So if I wanted to undo subtraction, I would do addition. If I wanted to undo multiplication, I would do division. And if I wanted to undo division, I would do multiplication.